Good afternoon, one and all. Myself, Narasimha, JL in Chemistry from Beechupally, Joglamba, Gadwal. I firstly thanks for giving this opportunity. Respected Secretary Sir, Deputy Secretary Sir, our Chemistry Coordinator Ma'am, and our college Principal Sir. Welcome to TREIS webinar classes. In this, I will discuss biomolecules. That is chapter 9, which belongs to second year chemistry. In this chapter, weightage 4 marks. They are giving 1 SAQ or 2 VSAQs. Biomolecules. Biomolecules means biomolecules means molecules that occur naturally in living organisms. Biomolecules include macromolecules like carbohydrates, proteins, lipids, and nucleic acids. In this type of food, we are observing the carbohydrates. Carbohydrate, how can you define the carbohydrates? How can you define the carbohydrates? The carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones are the compounds which produces such units on hydrolysis. These carbohydrates are the hydrates of carbon, hence the name carbohydrates, also known as saccharides. General formula of carbon X molecules and water molecules Y molecule. The taken for the example is glucose. The glucose molecular form is the C6H12O6. But all compounds which fit into this formula may not be classified as carbohydrates. Example, acetic acid fits into this formula. Sugars, carbohydrates which are sweet in taste. Majorly, carbohydrates are classified into 3 types: monosaccharides, disaccharides, and polysaccharides. First of all, how can you define the monosaccharides? The carbohydrate that cannot be hydrolyzed further to give simpler units of polyhydroxyaldehyde or ketone is called as monosaccharide. The examples are monosaccharides are glucose and fructose. Glucose and fructose. Next, oligosaccharides. How can you define the oligosaccharides? Carbohydrates that yield 2 to 10 monosaccharide units on hydrolysis. 2 to 10 monosaccharide units on hydrolysis. Further classified as disaccharides, trisaccharides, and tetrasaccharides. Disaccharides are nothing but combined as 2 monosaccharide units. Trisaccharides are nothing but the combined units are 3 monosaccharides. Tetrasaccharides are the combined units are monosaccharide units are 4. Next, polysaccharides. How can you define the polysaccharides? Carbohydrates which yield a large number of monosaccharide units on hydrolysis, not sweet in taste, hence also known as non-sugar. Example, starch and cellulose. Starch and cellulose. Further, carbohydrates are mainly classified into two types, reducing sugars and non-reducing sugars. Reducing sugars and non-reducing sugars. Comparison between reducing and non-reducing sugars. Reducing sugars reduce Fehling solution and Tollens reagent, but non-reducing sugars do not reduce Fehling solution and Tollens reagent. Okay, in this reducing sugars, all monosaccharides are reducing sugars, but not non-reducing sugars. Classification of monosaccharides. Classified based on presence of number of carbon atoms and type of functional group. Aldose. Aldose contains aldehyde group. Ketose contains ketone group. Different types of monosaccharides will be observed in this tabular formula. Carbon atoms is 3. The general term is a triose. In aldehyde observed in the aldotriose. In ketone, ketotriose. Carbon atoms 4 is there. The general term is the tetrose. Okay, in aldehyde form aldotetrose. In ketone form ketotetrose. Carbon atoms 5. The general term is considered as pentose. In aldehyde group aldopentose. In ketone ketopentose. Preparation of glucose molecule. First of all, what is the molecular formula of the glucose? The molecular formula of the glucose is C6H12O6. Okay, mainly preparation of glucose is the mainly two types. First one is the from sucrose, nothing but cane sugar. Second one is the from starch. Okay, first preparation method is the from sucrose. In sucrose, if sucrose is treated with diluted hydrochloric acid, sucrose is treated with diluted hydrochloric acid or sulfuric acid. In alcoholic solution, the equal amount of products will be obtained. They are glucose and fructose. Okay, what will be products are obtained here? Will be react with the diluted hydrochloric acid and sulfuric acid. The products will be same as glucose and fructose. This is the first preparation method of glucose. The second preparation method from starch. Starch or cellulose. Glucose is obtained by hydrolysis of starch or cellulose by heating with diluted sulfuric acid at 393 or 2 to 3 atmospheric pressure. The product will be obtained as glucose. Those are preparation methods for glucose. What is the structure of glucose? How will we exhibit in the glucose molecule? Glucose is also known as Dextrose. Glucose is also known as dextrose. This is aldohexose also. Glucose is monomer of many of the larger carbohydrates, namely starch and cellulose. Okay, the glucose is most abundant organic compound on earth. Okay, here in the right side tabular form, we observed into the glucose Fisher projection formula of the glucose molecule structure. The molecular formula of the glucose is C6H12O6. Next, structure was assigned based on following evidences. Nothing but how can you produce the glucose molecular formula structure? Some methods is there. I can explain. First of all, first method, the glucose molecular formula of was found to be C6H12O6. C6H12O6. The second one, glucose molecule reacted with hydrogen iodide. Glucose molecule with hydrogen iodide. In heating process, the formation of product is N-hexane. This second method, what will be suggesting that? Suggesting that all the 6 carbon atoms are linked in a straight chain in its molecule. Will be explained to the second method. Okay, next third one, what will be suggest that third method? The glucose molecule is react with hydroxylamine. Glucose molecule will be react with the NH2, which is the hydroxylamine to form an oxime. Hydroxylamine will be treated with the glucose. The product will be obtained as oxime. And second method also, glucose is react with hydrogen cyanide. In third method, glucose molecule is reacted with hydrogen cyanide. The product will be obtained as cyanohydrin. The glucose molecule will be treated with the hydroxylamine and hydrogen cyanide. Both reagents will be suggesting that the molecule, these reactions confirm in glucose molecule the presence of a carbonyl group in glucose molecule, suggesting that third method. Next, fourth one, glucose molecule is treated with bromine water. This is the mild oxidizing agent. The mild oxidizing agent will be treated with the glucose. Further oxidizing process, glucose will be converted into the gluconic acid. In this fourth method will be observed into the glucose molecule will be converted into the gluconic acid, will be used into the mild oxidizing agent is the bromine water. What is suggesting that fourth method? This indicates that the carbonyl group present is an aldehyde group. In fourth method. Okay, next fifth one, acylation of glucose. In fifth method, acylation of glucose with acetic anhydride. Acylation of glucose with acetic anhydride gives glucose pentacetate, which confirms the presence of 5 OH groups. 5 OH groups should be attached to different carbon atoms, will be suggested to the fifth method. Okay, next sixth one, Sixth one, here observe into the two oxidizing process, but the product will be obtained as only saccharic acid. Okay, an oxidation with nitric acid, both side, gluconic acid and glucose molecule will be oxidizing process with nitric acid, glucose as well as gluconic acid, both yield glucose as well as gluconic acid, both yield a dicarboxylic acid. Dicarboxylic acid, nothing but saccharic acid that has same number of carbon atoms, as glucose molecule. As this indicates the presence of primary alcoholic group, OH group in glucose molecule. Next, exact spatial arrangement of different OH groups in glucose molecule was given by Fischer formula. Its configuration is correctly represented as is the first one. The correctly represented as the glucose molecule is the first one. The second is represented as gluconic acid. Third one is represented as saccharic acid. In exact spatial arrangement of different OH group in glucose molecule was given by Fischer projection formulas. Is three molecular formulas is there. Here its configuration is correctly represented as the first one, that is the glucose molecular formula. Second one is represented as gluconic acid. Third one is represented as saccharic acid. Next, glucose is correctly named as D plus glucose. Okay. Here, see, observe here, right side the table formula, D plus glyceraldehyde and D plus glucose. Glucose is the correctly named as D plus glucose. D indicates configuration, plus indicates dextrorotatory. D indicates the positive, this is the dextrorotatory. Okay, next one, D isomer contains hydrogen atom on carbon attached to is a CH2OH of the lowest position in this projection formula. D plus glyceraldehyde also, and D plus glucose and glyceraldehyde and levorotatory glyceraldehyde. Observed here, bottom position CH2OH is there. Four structures CH2OH is there. Contains hydrogen atom carbon attached to CH2OH of the lowest position, and left side in Fischer projection formula is the L isomer. Hydrogen atom on the right side is the D isomer. Okay. Next, cyclic structures of glucose. The open structure of glucose doesn't explain the following facts and reactions. It does not give Schiff's reagent. Okay, it does not give the Schiff's reagent. In we observed the cyclic structure, does not give the Schiff's test. Second one, it does not form hydrogen sulfide addition product with sodium bisulfate. Third one, the pentacetate of glucose does not react with hydroxylamine. Fourth method, the glucose exists in two different crystalline forms, that is alpha and beta forms. Observe here cyclic structures. One of the OH groups add to the CHO group and form a cyclic hemiacetal structure. Cyclic and hemiacetal structure. Glucose forms a six-membered ring. Glucose forms a six-membered ring in which OH8 observed here in the diagrams alpha D plus glucose and beta D plus glucose. Glucose forms a six-membered ring in which OH at a carbon fifth carbon is involved in the ring formation. Okay, involved in the ring formation. This explains the absence of CHO group, and also existence of glucose in two cyclic forms. Two cyclic forms exist in equilibrium with open chain structure. Two cyclic hemiacetal forms of glucose differ only in the configuration of the hydroxyl group at C1, and this is called anomeric carbon. Here will be observed into the pyron and alpha D glucopyranose and beta D plus glucopyranose. Two cyclic hemiacetal forms of glucose differ only in the configuration of the hydroxyl group. Okay, differ only the hydroxyl group. In alpha D plus glucose will be observed into the hydroxyl group with the first position, bottom position. Beta D plus glucose pyranose is the observed into the first position. OH group is the top position. Top position is the beta D plus glucopyranose. Bottom position of OH group is the alpha D plus glucopyranose. Okay, such isomers are called anomers. Pyranose structure, six-membered cyclic structure of glucose. Six-membered cyclic structure of glucose. Next, fructose. Fructose is nothing but cane sugar obtained along with glucose by the hydrolysis of sucrose. Okay, structure of fructose. Here will be observed into the fructose. In glucose molecule, functional group is the aldehyde group. In fructose molecule, carbonyl group is the keto group. Mainly difference in the glucose and fructose. In glucose molecule will be observed into the carbonyl group is the aldehyde. In fructose molecule, carbonyl group is the ketone. Major difference in the glucose and fructose. Okay, structure of fructose. Molecular formula of the glucose and fructose is same. Molecular formula of the fructose also C6H12O6. Contains ketonic functional group at a second carbon and a sixth carbon in a straight chain. Here also D configuration. Here DO rotatory. D configuration of LEVO rotatory. Okay. LEVO rotatory means minus negative indication. Dextro rotatory means plus indication. Exist in the two cyclic forms which are obtained by the addition of OH at C5 to the carbonyl group. Five-membered ring called furanose is formed. Okay. Here also alpha D fructofuranose and beta D fructofuranose. Okay. Here will be observed in the fructose molecule furan. This is the five-membered ring. Okay. In glucose molecule, pyranose is the six-membered ring. two anomers of fructose represented by our structures. Okay, here observed the alpha D fructopyranose and beta D fructopyranose. Here will be observed into the second position, second carbon CH2OH and OH group will be observed into the OH group bottom position. Okay, bottom position of the OH group. This is the alpha D fructopyranose. The arrangement of only different in the alpha D fructopyranose and beta D fructopyranose is arrangement in the only OH group differ from second carbon. First alpha D fructopyranose is the position is second position, OH is the bottom position, and beta D fructopyranose is OH is the top position. Disaccharides, non-reducing sugars and reducing sugars. Reducing groups of monosaccharides, that is aldehyde or ketone groups are bonded. Example, sucrose. Okay, reducing sugars, reducing groups of monosaccharides are free in the group. Example, maltose. Next one is the glycosidic linkage. In glycosidic linkage will be observed into the two monosaccharides are joined together by an oxide linkage formed by the loss of water molecule. Okay, what will be observed here in glycosidic linkage? The two monosaccharides are joined together by an oxide linkage formed by the loss of water molecule. Such as a linkage is called as glycosidic linkage. Next, sucrose. Sucrose is nothing but cane sugar. Dimer of alpha D glucose and beta D fructose. Glycosidic linkage between C1 of alpha D glucose and C2 of beta D fructose. Okay, means glycosidic linkage in between the alpha D glucose. Here will be observed into the first carbon. Beta D fructose will be observed into the C2 carbon. Okay, here in sucrose, non-reducing sugar. Sucrose is the non-reducing sugar. Okay, this is the invert sugar. Okay, sucrose will be hydrolyzed. Sucrose will be hydrolyzed. Further, the product will be obtained as same products. Okay, same products are glucose and fructose. Glucose and fructose. Next, maltose. Okay, dimer of two glucose units. C1 of one glucose is linked to C4 of another glucose unit. This is also reducing sugar. Okay, maltose is the reducing sugar. Will be in this diagram will be observed here non-reducing end. This is the fourth carbon hydrogen and OH group. Here first carbon reducing end is the top position of the hydrogen and the bottom position is the OH. This is the alpha 1 to 1,4 glycosidic bond. Okay, this is the 1,4 glycosidic bond. How can will be formed into the 1,4? The removal of water molecule. In this formation of 1,4 glycosidic bond, the product will be obtained as maltose. Okay. Next one, lactose. Lactose is the milk sugar composed of beta D galactose and beta D glucose. Okay. Third one, linkage is between C1 of galactose and C4 of glucose. Linkage is between C1 of galactose and C4 of glucose. Okay. Reducing sugar, lactose is also reducing sugar. Reduce free aldehyde group at C1 carbon of glucose unit. C1 carbon of glucose unit. Here, observe into the structure of maltose and lactose glycosidic bonds. Okay, here alpha glucose and beta fructose. The product will be obtained as sucrose. The glycosidic linkage is the alpha 1, 2 glycosidic bond will be observed here. Okay, in alpha glycosidic bond is alpha D glucose and alpha D glucose. The glycosidic bond linkage formation is the removal of water molecule. Next, starch. Polymer of alpha glucose. Starch is the polymer of alpha glucose. Consists of two components. Starch is components of two molecules, amylose and amylopectin. Amylose and amylopectin. The major differences in between the amylose and amylopectin. Amylose is the soluble in water. 15 to 20% is the starch. Okay, in amylopectin, insoluble in water. 80 to 85% is the starch. Okay. Next, in amylose, unbranched chain of alpha D plus glucose units held together by C1 to C4 glycosidic linkage will be observed into the amylose structure. In amylopectin will be observed into the glycosidic linkage is formed by C1 to C4 glycosidic linkage. Branching occurs by carbon 1 to carbon 6 glycosidic linkage. This is the differences in between the amylose and amylopectin. Will be observed into the glycosidic linkages will be observed into the amylose and maltose. In amylose will be observed into the alpha 1, 6 glycosidic bond will be observed, and here in the bottom position alpha 1, 4 glycosidic bond will be observed here. In amylose alpha 1, 4 glycosidic bonds is there. Next, cellulose. Cellulose is the straight chain polysaccharide. Cellulose is the straight chain polysaccharide composed of only beta D glucose units. Beta D glucose units. These units are joined by glycosidic linkage between carbon 1 of glucose unit and carbon 4th of the next glucose unit. Here observed in the cellulose structure. Here beta links will be observed into the here. Here these units are joined by glycosidic linkages. Glycosidic linkages between the which carbons? Carbon 1 and carbon 4 of the next glucose unit. Next, glycogen. Storage form of carbohydrates in animal body. Glycogen is the animal starch. Glycogen will be absorbed into the liver and muscle and brain. Okay. Glycogen is nothing but glucose. Glycogen is nothing but glucose. Importance of the carbohydrates. Carbohydrates importance is the essential for life. Essential for the life. Forms of major portion of our food items. Okay. Third one is the used as storage molecules. Used as storage molecules. Fourth one, furniture and clothes. Carbohydrates will be absorbed into the furniture and clothes. Okay. Next, fifth one, raw materials for industries. Okay. Once again, recall, essential for life will be used into the carbohydrates. Forms major portion of our food items. Third one, used as storage molecules. Okay. Fourth one, furniture and clothes. Okay. Fifth one, raw materials for industries. Raw materials for industries. Proteins are will be absorbed into the these type of food items. Okay. All proteins are polymers of alpha amino acids will be absorbed into the protein food items. Amino acids. Amino acids contain amino group means NH group and carboxylic group. Carboxylic means functional group. Okay. Depending upon relative position of amino group with respect to carboxyl group, the amino acids can be classified as alpha position and beta position and gamma position, delta and so on. Okay. In amino acids, only alpha amino acids are obtained on hydrolysis of proteins. Alpha amino acids are obtained on hydrolysis of proteins. Natural amino acids will be observed here. Alpha amino acids, R means side chain, nothing but alkyl chain. Name of the amino acids: glycine, alanine, valine, leucine and isoleucine. Structures will be observed, characteristic features of the side chain. Okay. Glycine will be, letters will be observed in the one letter code is the G. This is nothing but GLY. Okay. Alanine, ALA. One letter code is the A. Valine, letter code is the V. Leucine is the same as isoleucine. Okay. These are natural amino acids. These also natural amino acids are isoleucine, arginine and lysine, glutamic acid, aspartic acid, glutamine, asparagine, threonine, serine, cysteine, methionine, phenylamine, tyrosine, tryptophan, histidine and proline. These are also natural amino acids. Properties of amino acids. Amino acids are colorless. Amino acids are colorless. Crystalline solids. Crystalline solids. Water soluble. High melting solids due to presence of both acidic and basic groups. These behave like salts rather than simple amines or carboxylic acids. Zwitterion. Zwitterion means this is the reversible reaction. Okay, this is a product and B product as well as same. This is nothing but jitter ion. In aqueous solution, carboxyl group can lose a protein and amino group can accept a proton. In aqueous solution, carboxyl group can lose a proton and amino group. Okay, will be absorbed into the jitter ion. In NH2 group and CW1OH group, the loss of proton and amino group can accept a proton, giving rise to a dipolar ion. Dipolar ion known as jitter ion. Neutral. This jitter ion is the neutral. Nothing but contains here will be absorbed into the both charges, positive charge and negative charges. Positive charges as well as negative charge. What will be absorbed into the jitter ion? Here the loss of hydrogen means proton and amino group. The product will be obtained as jitter ion. In jitter ionic form, amino acids show amphoteric behavior. All alpha amino acids except glycine are optically active. Okay, all alpha amino acids are optically active, but not glycine, since the alpha carbon atom is asymmetric. Alpha carbon atom is the asymmetric carbon. Exists both in D and L notation forms. Okay, what will be observed here? Exist both in D and L forms. Most naturally occurring amino acids have L configuration. Okay, most natural occurring amino acids have L configuration. L configuration is nothing but NH2 group on the left side of the position. Okay, NH2 group on the left side of the position. Okay. Next, the classification of amino acids. Majorly classified as amino acids are mainly three types: acidic amino acids, basic amino acids, and neutral. Okay. Further, amino acids are mainly classified as two types: essential amino acids and non-essential amino acids. Essential amino acids and non-essential amino acids. Neutral amino acid, nothing but equal number of amino acids and carboxylic group. Okay. Neutral amino acid is nothing but the equal number of amino groups and carboxylic group. That is considered as neutral amino acid. Okay. What will be observed in the basic amino acid? The basic amino acid, more number of amino acids compared to the carboxylic groups. More number of amino acids will be compared to the carboxyl groups. So this is called as basic amino acid. Okay, what will be observed in the acidic amino acid? More number of carboxylic groups than that of amino groups. This is considered as acidic amino acids. Classification of proteins based on their molecular shape: fibrous proteins and globular proteins. Okay, the major differences in between the fiber proteins and globular proteins. Fiber-like structure is formed when the Polypeptide chains. Polypeptide chains run parallel and are held together by hydrogen and disulfide bonds. Okay, in globular proteins, the formed when the chains of polypeptides coil around to give a spherical shape. Okay, fiber proteins are insoluble in water, but globular proteins are soluble in water. Okay, next fiber proteins are example is keratin and myosin. Keratin and myosin. In globular proteins will be observed into the example insulin and albumin. Insulin and albumin. Structure of proteins. Alpha amino acids connected to each other by peptide bond. Alpha amino acids connected to each other by peptide bond or peptide linkage. Peptide linkage is a amide formed between COOH group and NH2 group. Okay, here peptide linkage is nothing but the base group, means amine group and COOH group will be observed into the glycylinin. Okay, will be observed in the peptide linkage is attached to the carbonyl group and NH2 group. This is the structure of protein. Okay, the primary structure of proteins will be observed in the structure formation. The specific sequence of the amino acids in the polypeptide chain will be observed into the amino group. Here amino acid will be a straight chain. Here specific sequence of the amino acids in the polypeptide chain is the primary structure will be observed in this diagram. Okay. The primary protein structures is the...
Sir, conclude the session, sir.
Okay, thank you, sir.
Okay.
Okay.